And I want to get you first a large-scale view of the universe. This is a picture of the universe as seen by the Sloan Digital Sky Survey, a telescope located down in Arizona. And it's the color coding there is an indication of distance, how much redshift is going on. And that can see back to almost 12 billion light years into the past. The look-back time is 12 billion light years. The distance is actually about twice that because the universe has continued to expand since the light has left that. The universe really is not shaped like a fan or anything. This is just a cross-section through the observable universe from Arizona. Obviously, it can't see the sky below the horizon, and the Milky Way gets in the way of seeing distant galaxies, and also the dust in the plane of the solar system interferes. So this funny-looking figure is a cross-section of what it can actually cover in the sky. Now, we can see light that left over 12 billion years ago. Now, the new James Webb Space Telescope can see galaxies back to 13.4 billion years ago, only 400 million years after the Big Bang. Now, zooming in on a redshift of 0.15, or about 2.7 billion light years, we see the filamentary structure of the cosmic web. This is nearby enough that we can see this structure upon which the arrangement of galaxies condensed. It's composed of strings and clumps of galaxies called clusters and superclusters, and the great voids between them with almost nothing there. Now look at the central region, about 2 billion light years across. This is the local universe, 2 billion light years across, containing dozens of superclusters of galaxies and the great voids in between them. You are, I don't know if this is, there we go. You are right here in the middle. We like to put ourselves in the center of the universe, even though it really isn't. And right in the center, that yellow rectangle, is Laniakea. Now, Laniakea is a Hawaiian word meaning immense heaven. And it's composed of 5 superclusters, 100,000 galaxies, 520 million light years across, and it includes the 5 superclusters, Centaurus, Proto-Indus, Southern, Hydra, and Virgo. That's where we live, in the Virgo supercluster. And you can, there's the Centaurus cluster out there, Pavo-Indus out there, the Southern supercluster, the Hydra supercluster, and here in the middle is that red outlined region is the local supercluster, and that's what we're going to be exploring today. And you are here, a little bit offset from center. Now here is a blow up in the plane of the supergalactic plane is the plane of that circle there. And the biggest member of the Virgo supercluster is this gigantic cluster called the Virgo cluster. It's on the northern part of the constellation Virgo in the sky. And again, here's the local group. M101 is over there. M81 and M82 are there, etc. So this is our backyard, and that's where we're going to be playing around today. Zooming in still further, you see our local group. And in the center is the Milky Way and the Magellanic Clouds. Over here is the Andromeda Galaxy. the Triangulum Galaxy. And looking very much closer to the Milky Way and the Magellanic Clouds and several small dwarf galaxies that seem to be gravitationally bound. Now, turn it on its side again, and this is another way of looking at the Virgo supercluster. Again, that area outlined by the red ellipse, about 120 million light years across. And again, there we are in the middle. Now, the green dots that you see appearing there, these are the galaxy clusters that I have so far explored and that I'm going to take you with me on a tour. The individual galaxies in the clusters are grouped together on the sky, but when this assignment was done, we didn't necessarily know the exact distances to all of these galaxies, and so they may not be physical members of a cluster, but much further behind the cluster or closer to us than the cluster. Now, this is my spaceship. It's a space-time ship as well as a spaceship. Oh, it's actually a C-14, but I have it on a Losmandy mounting with the Gemini 2 system on it, which is a very good system. I use this software, SharpCap, and you need to get the Pro modification that costs $18 a year, but that gives you live stacking. You can also get it for free in the ASI Studio from ZW Optical, but I've never quite adjusted to using that. I like the one in SharpCap better. Oh, by the way, some of the closer galaxies in the local group, I use this much smaller telescope that covers a wider field to get them. Here's the setup I use. My C14 has a native focal ratio of f11, which doesn't give me a very big field, so I put the Starizona 0.63x focal reducer on it, bringing the focal ratio down to f7. And I use either an ASI 294 MC for the earlier work I did. I'm currently using an ASI 533 MC. Both are one-shot color cameras. So I will not be playing with red, green, and blue filters. I won't be playing with hydrogen alpha. I won't be playing with sulfur 2 or oxygen 3. This is just one-shot color camera and no guiding, just using the live stack procedure. There's no guide scope, no off-axis guider, no on-axis guider. Now, looking back at the local group again, we see the Andromeda Galaxy over here. This is the big bruiser of our group. And the M33, the Triangulum Galaxy, considerably smaller than either Andromeda or the Milky Way. And we have a bunch of tiny dwarfs. And the volume of our local group is that sort of blue oval you see there. Next to it is the Sculptor group, which I can't see from New Jersey. And I suspect that if Charles Messier had been able to see below his horizon, he probably would have included this particular galaxy in his list of annoying objects, and we would probably call this a member of the local group now. But it's too low for me to get an image of it, though. Now, the only way I can take a picture of the Milky Way galaxy is from the inside, since I don't have warp drive on my spaceship. But this was a view I took from West Texas several years ago with a little ASI 120 MC camera with a fisheye lens on it. And you can see the constellation Scorpius, Aquila, the eagle up there, and Sagittarius. And in the middle of Sagittarius, we find this structure, which is hard to see in this light, Sag A star, which is the black hole in the center of our galaxy that was recently been imaged by the Event Horizon Telescope. And if you look in the infrared, you can actually see stars orbiting that in very fast orbits. This is what it looks like from above if I had warp drive on my spaceship. It is a barred spiral galaxy, not a classic spiral. And the solar system is located right about there. And these are the nearby large and small Magellanic Clouds. And that's about to scale distance they are from the Milky Way. Now, if we look at this constellation picture showing part of Andromeda and part of Triangulum, we see where did that pointer go? Well, the big oval in the upper right is M31, and M33 is closer to the center. Oh, I touched the button I wasn't supposed to touch. Here is my picture of M31 taken with the little 70 millimeter Astrotech telescope, and you can see the satellite elliptical galaxies M110 and M32. It's big, relatively close to our galaxy, and if you can see the full extent of it, it's about 6 times the size of the full moon in the sky. Great object for binoculars if you've got a very dark sky. Now, when the light which formed my image of M31 began its journey 2.6 million years ago, genus Homo, including Homo sapiens, Homo neanderthalensis, was just a gleam in the eye of this lovely Australopithecine Eve. Hey, Grandma. M31 is on a collision course to the Milky Way and will merge with it in 5 million years to give a new galaxy after it settles down, which we will probably call Milkimedia or something like that. It should be a spectacular sky show when that happens. I hope we survive that. Here's M33, the spiral galaxy in Triangulum. This was again taken with the little telescope. It's too big for the field of my big one. Now, here's a couple of galaxies that most of you have never heard of. They happen to belong to the closest galaxy cluster to the local group, the Maffei cluster. There's 2 of them. Maffei 1 is an elliptical galaxy. Maffei 2 is a barred spiral galaxy, and they're only 9.3 million light years away, much closer than M101 or M81, M82. The reason you can't see them is because they're located in Cassiopeia, and an arm of the Milky Way goes through there. There's so much gas and dust in the way that we can't see it, but you can see it with infrared. And this was a 2-mass survey image at 2 microns. Now, my cameras will go down almost to 2 microns, so I think I'm going to try a near-infrared filter and see if I can image it, but I haven't been able to do it yet. I suspect these are going to be targets of the James Webb. I haven't heard of them going after them yet. Now, we look over in Sculptor. Remember I told you there was one that would be a member of the local group if we had known about it earlier, probably. It's only 15 degrees of the horizon in New Jersey. I might be able to get it, but I'm going to try. This was a picture taken by the European Southern Observatory down in Chile. It's a nice spiral galaxy. Now, while I'm talking about ones I can't reach from New Jersey, we have this Centaurus A, a very powerful radio galaxy. It's definitely 4 degrees below my horizon. I will never get a picture of this one. It's a massive black hole in the center, 55 million solar masses. And this lovely spiral galaxy, M83, I have a good chance of getting this, but I might have to use a chainsaw on my southern horizon. Now up to Ursa Major, a lot of galaxies that I can reach. We have a number of galaxies in Ursa Major and also in Canem Spinatici. We go over to the next closest group, M81 and M82. M81, also called Bode's galaxy, is 12 million light years away. And this picture I have here is a live stack of 132 frames for a total integrated time of 22 minutes exposure. And on the right, you see M82, sometimes called the cigar galaxy. It's even just a little bit closer, 11 million light years away. And it's a very active galaxy. If you can see it in this light, there's a red cloud of ionized hydrogen going above and below the plane of the galaxy, probably shot out from the excitement going on around its central black hole, the accretion disk there. In Canis Venatici, we have M94, 16 million light years away, and M16, M94, 16 million light years away, and M64, 17 million light years away. These are both very strange galaxies. M94, the rotational velocities appear to be explained perfectly by just the luminous matter in this galaxy. And that implies there's no dark matter in this galaxy. And the black eye galaxy, M64, is even stranger. It's got two counter-rotating disks of stars. Seems to be the result of a merger of two galaxies that were rotating the wrong way, or the opposite way. And there's so much space between the stars that they can do that without having collisions. So, by the way, if you are a believer in the modified Newtonian gravity theory for explaining anomalous rotation in galaxies that have to have extra mass in them, this galaxy here is a counterexample. It ought to be rotating that way too, and it doesn't. It's purely Keplerian rotation in this galaxy. There's a few other targets in this particular group. I haven't got them yet. I'll show you my score sheet at the end of the... now this is M51, the beautiful Whirlpool galaxy. It's 23 million light years away. And I don't know if you can see it, but there's a streak of light running right up through here. And, by the way, that's NGC 5912, which is on a collision course with M51. But there's a satellite trail, probably Starlink. I got photobombed by Elon. And it got fainter when other images were stacked on top of it. But I think there's a setting that can reject things with streaks in them automatically, and I haven't figured out how to do that yet. M63 is also in the M51 group, 27 million light years away. This is 61 frames for only 10-minute exposure. It's called the Sunflower Galaxy because it sort of looks like a flower. One more in this group I haven't targeted yet. I hope to get 5023 if I can get some clear, non-smoke-filled skies in New Jersey someday. Now, M101 is the next, its group is the next further group away. It's 21 million light years away, 1.7 times as big as the Milky Way. There's a couple of small galaxies in the group, NGC 5424 and NGC 5204. And that's the general direction they are from M101, but they're a little further away than I can show on this screen. Now, some excitement happened in M101. This is my picture of May 27, 2023. A few days earlier, Koichi Itagaki reported a supernova present in this particular galaxy, and I missed finding it by 4 days. It's supernova 2023 IFX, discovered on 19th of May, and the progenitor was found on an old Hubble plate. 27th magnitude, and it blew up and got as bright as about 10th magnitude. It peaked 10.5. These are my measurements. I didn't do the first 4. I think this is my first measurement, and the rest of these are my measures of the brightness. I used aperture photometry to measure this, and the last measure on the right is last Friday, a week ago. So it's now this was the discovery magnitude, and it's back down to the discovery magnitude. I'll continue to monitor it and probably send my stuff into AAVSO. I'm neglecting reporting stuff. Now, the second Canis Venatici group has this M106. It's a type 2 Seyfert galaxy. I think it's the closest Seyfert galaxy to our local group. It's 24 million light years away and has a 39 million solar mass black hole in the center. There's 4 other members of that group that I have not yet imaged. They're quite small. Now, in Draco, we have a group of galaxies that belong to in the same group as M102. But it's interesting that there's a lot of galaxies in this area, but they're not really associated with it. The ones that have a gold center are all around 40 million light years away. But if you look at some of these other ones, they're as far as 150 million light years away, and they're way on the other side, outside of the local supercluster, probably in the edges of the Draco supercluster. Here's NGC 5896. We call it M102, but nobody really knows for sure if that's the galaxy that they were talking about when they called it M102. But it really is NGC 5896. It's an edge-on lenticular galaxy in Draco, 50 million light years away. And this is NGC 5907, 55 million light years away, certainly the right distance to be in the group with M102. We also have NGC 5879, 56 million light years away, and this nice little pair, NGC 5963, which is part of the M102 group. It's a little closer than the average, but this other one is a huge spiral, barred spiral galaxy, but it is 150 million light years away, clear on the other side of the sky compared to this group. Now, if we look in Leo, there's a lot of galaxies in Leo. We first have this nice grouping around M105, NGC 53384, and 3389. They're about 32 million light years away. And M95, a barred spiral, it's 33 million light years away. And M96, another barred spiral, 34 million light years away. And the Leo triplet, which is a favorite imaging target for amateurs. Here's M65, M66, and I couldn't fit the other one in, so this is a mosaic. They actually overlap in this region, so if I had photographed them with a small telescope, I would get a slightly smaller scale image like this. That's all 3 of the members of the Leo triplet. Now, the realm of galaxies. Why is Leo called the realm of galaxies? If we just look at the Messier objects only, we see a few of them, M65 and M66, and another group around M105. But if we go down to 10th magnitude NGC objects, a whole lot more show up. 11th magnitude, still more. 12th magnitude, a whole lot more. And all of them, wow, galaxies all over the place. And this concentration right here is actually the Virgo cluster, just outside of the edge of of Leo. And here they are in the constellation. Where did that go? Okay. Up here, this is the Virgo cluster, and here's M104, another cluster. I'll show you the M104 group first. This is the Sombrero galaxy. It's 29 million light years away. And I love this picture taken by the Herschel Space Observatory in the infrared. You see right clear through to the middle of the galaxy, seeing through the dust and gas. M104 is also associated with NGC 4504, 4487, 4802, and UGCA 289, but it's probably not gravitationally bound to them. Here's 4504. It's a small barred spiral galaxy. 4487, another small barred spiral galaxy. And did I do too many? No, that's all. Now, the Coma 1 group is near Virgo and a little bit further away. And it has a number of groups, including this grouping. This is not a very bright, well, I'll show the pictures of them. The Coma 1 group includes this beautiful galaxy, NGC 4565, commonly called the Needle Galaxy. It's a nice barred spiral, and there's something about barred spirals that you can recognize them from the side. The nucleus of the galaxy sort of has a lumpy cross-section, sort of like you're looking at Mr. Peanut from the side. But that's a barred spiral, 140,000 light years in diameter. Nearby is NGC 4725, which my son insists is Darth Vader's TIE fighter, and NGC 4559. These are in the neighborhood of 30 to 40 million light years away. Also in the difficult for me to reach area is the NGC 2997 group. It's in Antlia. It could be 9 degrees above the horizon, but again might need a chainsaw for me to see it. It's a beautiful spiral galaxy. Now back to the Virgo cluster. They're a little bit, I'm doing this by distance mostly, and the Virgo cluster is a little bit further away. They're all up here in the upper part of the constellation Virgo, the northern part. This is an overlay of pretty much all of the galaxies in the Virgo cluster, and there is a blow-up of it. The average distance of about 50 million light years is in the direction of the constellation Virgo, more than 2,000 galaxies in this cluster. It's the heavyweight of the Virgo supercluster. The largest concentration near M87 is called Virgo A, and it's about 5 million light years in diameter. Of the galaxies in Virgo, 58% are spirals, 27% are ellipticals, and the rest are irregulars. Now, even though spirals are more numerous, the 4 brightest galaxies in this group are the giant ellipticals, among them M87. Here are the 4 brightest galaxies in the Virgo cluster. M85, no, what is that? I can't even read it myself. Sorry about that. I should have used white letters on that. M89, M87, M60, M80, and M85, and the big spiral, M100. And another elliptical, M84, and another small barred spiral. Now they have some interesting features in them. Another small galaxy looks like it's about to collide with this particular elliptical, and I'm not quite sure what that thing is next to that one. However, in this galaxy, there was a supernova a couple years ago, and again, our friend Koichi Itagaki discovered it. I guess he's a pretty prolific supernova finder. Here is a better picture I've got of M87. I actually took this by the same lucky imaging techniques I use for planets, and I get a much sharper view of it, including seeing the jet coming out of the central region. It's going at 0.999 times the speed of light, almost as fast as the speed of light, but not quite. There's a 6.5 billion solar mass black hole in the center of this galaxy, and the accretion disk around the black hole powers the relativistic jet perpendicular to the disk. Now, early estimates, they thought it was going 6 times the speed of light. Now, this was kind of scary, but they figured out that this is a relativistic illusion caused by the fact that it's almost pointed directly at us, and that gives us an illusion that it's going faster than the speed of light. The actual velocity is very close to, but not greater than the speed of light. Einstein can rest in peace. The shadow of the central black hole has recently been imaged by the Event Horizon Telescope, a composite formed from the linkage of radioscopes from all over the Earth. So it's effectively a radio dish the size of the Earth. And you can see the shadow of the black hole. That's what this area here is. And this is light that is refracted around the black hole by the gravitational lensing effect of the black hole itself. The brightest spiral is M100, and it's 55 million light years away. And nearby there are several small galaxies, either irregulars or ellipticals. They're the right distance to be part of the Virgo cluster. They're not big things very far away. They're little things at the same distance as M100. Now, the Virgo 3 group, that includes a chain of galaxies extending to the off to the side of the Virgo cluster, and they're a little bit further away. They include NGC 5248, 5364, 5566, and 5638, and 57446. Now there's the Ursa Major clouds south and north. The south one I've indicated in red. That's the I need a high-powered laser. I think where the battery's running down. NGC 4051 over to the left of where it says Ursa Major. That's the south group, and the north group are up in the bowl of the Big Dipper. These are getting pretty far away, 47 million light years away for this little barred spiral galaxy, 53 million light years away for this spiral galaxy, and another barred spiral, 4051. And the north cloud includes this little spiral galaxy, NGC 3631, and 3556, which is Messier 108, and this nice barred spiral, NGC 3953. But this is one of my favorite ones, M109. Again, this is a Messier object that was added to the list, but not by Charles Messier. It's the highest number in the list. But this is a very nice barred spiral, but it's 85 million light years away, probably outside of the local supercluster, and it looks remarkably like the Milky Way. This is what the Milky Way would look like from 85 million miles away. It's a little bigger than the Milky Way, though. It's a beautiful example of a barred spiral galaxy. It's about twice the size of the Milky Way, and it's well beyond the members of the Ursa Major Cloud North group. The Draco Trio, that's very close to the same area, near Ursa Major. And it's a beautiful little grouping of galaxies, a lot like the Leo triplet, but a bit closer together. Here's a blow-up of where they are in between Theta and Adasic stars in the constellation Draco, and very close to M102. Here's the three of them. I got this in one image, NGC 5981. It's 135 million light years away. That's outside. 5982, 130 million. NGC 5985, 120 million light years. The whole cluster is only 120 million light, the whole supercluster is only 120 million light years across. So these are definitely outside. We have left the local supercluster. I plotted it out on this plane with the supergalactic coordinates, and the Draco Trio is right up there. And this arrow is 100 million light years long. So this is tilted towards us a little bit, so it's a little longer. But even further out, I looked back at my picture of M51 that I got photobombed by Elon, and I noticed that there's a little tiny smudge right up there. See that little smudge? That turns out to be IC 4278, 230 million light years away. Plotting it on the picture of Laniakea, it's not only outside of the Virgo supercluster, it's outside of Laniakea. So I think that's as far as I'm going to go for now. Here's my score sheet that I'm keeping track of the different galaxy groups in the local supercluster. The blue ones are the ones I got early in my investigation. The red ones are recent ones. The white ones are things that I'm going to be trying to image. And the sort of gold-colored ones, those are ones that are either too low or obscured by the arm of the galaxy. But I had to add the little one that I saw past M51. So that's all. Questions? Yes?
For the main core of the Virgo supercluster,
Yeah.
what's the angular extent?
Oh, it's completely around us.
No, I mean, how many degrees, how small or large is it on the sky?
It covers pretty much the whole sky. I mean, we're inside of it.
The one, give it in your...
Oh, you mean the Virgo cluster itself,
Yeah,
not the Virgo supercluster.
Oh, sorry.
I'm sorry. I thought the super. We go back here to the image of the constellation Draco of Virgo, and there you can see it. Each one of those vertical divisions is 10 degrees, and if I remember roughly the size of that square I put up there, it's about 10 degrees square. It's a big chunk of sky, and there's a lot more galaxies there than I have specifically tried to image.
If you did a fast astro camera that could cover it maybe in one or two shots,
Yeah.
would you get many of them, do you think? Or?
I think I could. I would probably want to go with that f6 70 millimeter. I could probably get a lot of them. I wouldn't resolve much detail in them because they're pretty far away, but I should show a good sprinkling of them there. But a lot of them there. Yes.
How long have you been doing this?
About a year and a half. Yeah. So yeah, I'm thinking of kind of turning it into a supernova patrol. I got very close to finding supernovas, but a few days after somebody discovered them, I was taking images of M51 back in around 2005 or something, and I got a picture of M51, normal picture of M51, and it started raining for about a week and a half. And during that week, an amateur in Germany discovered the supernova at M51, and I took my first image of it. There it is, But this kind of live stacking technique would be ideal for doing a supernova patrol, because it doesn't get the beautiful pictures that you get by taking the long exposures through different color filters and things of that sort. But I don't think you can mount a supernova patrol if you're doing that. So, but I find it very rewarding, and I can cover a lot of ground pretty quickly, and it's easy to do. So, any other questions? Let's see, way in the back.
Early on you mentioned the magellanic clouds. I remember reading a couple years ago that they might not necessarily be gravitationally associated with the Milky Way. Have you heard anything about that? Has anybody heard anything
About the Magellanic Clouds? Well, they're certainly tidally distorted by the Milky Way. You can see that. So my guess is that they're on orbits that are going to take them a lot closer at some point. But I haven't read anything recently about it, and the tidal distortion is the only thing I know for sure.
Yeah, I read something about it a couple years ago. I didn't see any kind of follow.
Yeah. No. Yes? Well, I would like to ask somebody to explain that one galaxy to me, because I really kind of like the idea of MON better than all this dark matter that you got to spend so much money to make the collider bigger so you can find it. But it's beginning to look like it's going to be probably something like neutrinos. There's enough of them, and they can self-annihilate. Some of these things they're discovering with the James Webb. Looks like they found very early in the universe stars that are powered by annihilation of dark matter. A neutrino can self-annihilate because it's its own antiparticle. But the fact that most galaxies show this strange rotation curve that you would think, if Keplerian dynamics were going on, the outer ones would just be thrown away. And so you need more mass to explain those. But then, why, we've got a galaxy that does obey Keplerian dynamics. So if you're going to do MOND, it's got to affect everything. So I haven't read anybody's response to that, though. Yeah.
Comment there.
Yeah.
Just in the last month or so, traditionally they test MOND with galaxy rotation.
Yep.
But they've just, I think it was out of Japan or something, maybe China, there's a study where they look at very wide binaries that have accelerations below a tenth of a nanometer per second squared.
Yeah.
And that holds up with MOND.
Really?
So that's in our galaxy, and I think that's the first time that's been tried. And so, as bizarre as it sounds, it's getting some additional support just in the last month.
Interesting. But of course, if dark matter is real, there's dark matter around them too.
Yes,
Yeah.
right.
So, it's going to be interesting, and particularly with the new things found by the James Webb. Isn't it a great time to be an astronomer? So,
Always has been.
anything else? Yes, Eileen.
The lenticular galaxy 5896.
Yep.
Did you do anything special to get that double image?
The double image of the lenticular.
Lenticular, they look like two cores.
Well, that's caused by the dust lane in the equatorial region. So it's we're seeing both above and below, and it's called lenticular because probably if we were looking at it from above so we could see down on it, we wouldn't see any spiral arms. But it does have dust in the equatorial plane, and that made the dark line. Yeah. Okay? Thank you.